1200. Hello, so in this video we are going to talk about what is half-life, what is double time. So first, what is half-life? So half-life is how long does it take for the radioactive isotope to reduce to half of its original quantity. So for example, in this one, Cesium 137, the 137 is not a meaningful number, it's just the name of that cesium, has a half-life about 13 years. So if you begin with 200 milligram of cesium 137, how much will remain after 13 years, 60 years, and 19 years? So it tells you that, hey, the half-life is 13 years. That means after 13 years, the cesium is going to remain 50% of its original mass. So original, the mass is 200 milligram, right? Its half-life is 13 years. So after 13 years, it remains half of what it can originally, which is 100 milligram. And then after another 13 years, which is 60 years, right? You add another 13 years. After another 13 years, you're going to remain another 50 milligram. And then after 19 years, that means another half-life from the 60 years. So you will remain half of what you have remained after 60 years, which is 25 milligram. So this is the definition of half-life. Remember, half-life, it doesn't mean the time. It means how long does it take for the substance reduce to 50% of its original mass. So here is an example. A carbon-14 is a radioactive isotope that is presented its origin organic material and is commonly used for dating historical artifacts. So carbon-14 has a half-life of 5,730 years. If a bone fragment is found that contains 20% of original carbon-14, how old is the bone? So since it's a radioactive decay, so this is going to be a continual decay. So the formula that we should use, it should be Fx equals to the original amount times E, because it's continuous. The decay happens every single second. The rate to the time. So now we know that, hey, if the original, we don't care about what would that be. What would be the original, the mass? Let's say the remaining would be 20% left. So that means the output is going to be 20% of the original A times E to the R. The rate we don't know, and we're trying to find the T. E equals to 2.718. And then in here, since they both have A, they can reduce the A, right? They can cross cancel A. So I have 0.2 equals to E to the R to the T. We're trying to solve for T. So as we know, we are trying to solve this one, the T, but now we have another unknown variable, which is R. So in order to solve T, we need to know the R, the rate. What will be the decay rate? So what information they give you? So they give you that, hey, the carbon-14 has the half-time life of 5,730 years. So that means the reaction, the mass of these fragment, the bone, is going to be what? 50% left after the rate that we don't know, after 5,713 years. We can use these sentences, these equations, to solve our R. Because if in one equation, we can only solve one unknown variable. In the previous one, we have two unknown variables, so that we can solve the T. So we can find out the R by solving the half-life. So since half-life means only 50% left. Okay, since they both have a, I can divide the 8 on both sides. So I have 0.5 equals to e to the 5730 times r. Again, so now we have the variable in the exponent. In order to undo the exponent, we need to we write this into a logarithm function. So how do we do that? What's the base? The base is this one, right? So I have log to the e, which is what? The natural log. So we can write this is natural log and then swap these two, right? So when I swap it, I have natural log to the 0.5 equals to 5713 times r. To solve r, we can divide it by 5713 on both sides. So our r equals to log natural log ln 0.5 divided by 5713. Okay, so now let's use our Google calculator. So I have ln 0.5, and then we want to divide it by 5713. So this is equal to our rate, which is negative 0.0001209689. So that makes sense because it's decay really slow. That's why it takes 5,713 years to decay to half of its size, of its weight. So it's really slow decaying. So after we know the rate, the next thing that I want to do is find out about the time. We go back to our first unsolved part in here. We have 0.2 equals to e to the r, which is negative 0.0001209689 to the t. Okay, so now we can solve t by what? Undo the exponent using logarithm function. I have ln, because it's natural log. If you are still uncomfortable with natural log, you can still write it as log base of e 0.2 equals to r times t. I'm going to keep it r because it's easier. And then I divided r on both sides. That's it. And then I can use a calculator. If you want to write nicer, it should be ln of 0.2 divided by r, that's equals to our t. So in our calculator, they have a function which is keep the answer on the lower right or lower left corner. So what we can do is we can just keep the r here because our r is our answer. We don't need to close up everything. I have ln ln 0.2 and then and divided by our r, which is our answer, right? So I can choose the answer. Oops. Okay, let's see the time. So it takes 13,304 years, 6 years. So our r equals to 13,305 years. So that means the bone dating back to what? The bone is 13,305 years old. Okay, so this is half-life. So we can use the given information, which is the half-life, to calculate the decaying rate. So another concept is doubling time. Doesn't mean you double the time. This means how long does it take for the mass to grow double of its original mass. So that means if your original weight is 100 milligram, so maybe the double time means how long does it take for this material to grow to 200 milligram. So this is called doubling time. All right, let me find you an example. So let's make up one. If you invest money at 8% compound quarterly, how long will it take your money to double? Okay, so this is a compound interesting problem. So that means the formula we should use is fx equals to the original amount times 1 plus r divided by the compound frequencies to the k to the t, right? And we don't know the initial amount, but does it matter? It doesn't matter because eventually they could get cancelled out. We know that fx, we want it to be double. If the original amount is a, after double you should have 2a. And the rate is 8%, and the k is compound quarterly. That means they compound 4 times within a year, and we're trying to find out the time. Okay, so we substitute everything that we know and try to solve the time. Okay, so now we know that a, they can both divide it by a. So 2 equals to 1 plus 0.02 over 4t, which is 2 equals to 1.02 to the 4t. And then, how do we, I just want to make sure that you understand. We divided by a on both sides, since they both have a, so that we can just divide a on both sides. Okay, so now there is a exponential, right? We want to solve the variable in the exponential position. To undo that, we need to use a logarithm function. So the base should be the same base as the exponential function, which is 1.02, and then you swap these two. So you have log 2, which is equals to 4t, and then 4 times t, you divide by 4 on both sides. So that means your t equals to log base of 1.02 of 2 over 4. So how can I calculate this in a calculator? So here I'm going to show you. So first we can calculate the logarithm first. Alright, so how do we calculate logarithm? Well, we can either put log 2 over log 1.02, right? And then divided by 4. So we can calculate the top of the fraction first, which is I can use ln or I can use log. So ln 2 divided by ln ln of 1.02, which is equal to our numerator, and now we divide it by 4, that is 8.75. So that means it takes about 9 years or 8.75 years to double your investment in this account. Okay, let's try another example. So use of a new social network website has been growing exponentially, with the number of new member doubling every 5 months if the site currently have 1,200, no, I'm sorry, 120,000 users, and this trend continues, how many users will the site have in a year? So the first thing is we want to find out the output. The first thing we always want to know what is the rate. The rate equals to what? Now they're giving you that, hey, we're starting with 120,000 and the number doubling every 5 months. So that means when we set up the equation, we don't even need to worry about when we're trying to find the rate of the doubling time. We don't even need to worry about what is the exact original number, because we know that the A is going to cancel. So we know that, hey, the formula, this is exponential growth, is going to be this one, right? It's not compound interest, it's not a continuous growth. All right, so doubling, that means the output, when the output equals to 2a, it takes the time equals to 5 months. And we're trying to solve that. First step, again, it doesn't matter the a. We cancel this. We have 2 equals to 1 plus r equals to 5. So how can we solve this? Is this an exponential that we are trying to do before, that convert this to a logarithm function? No, because this is in the base. They're not in the exponential position. How do we do that? Don't learn something new and forget something old, okay? So to do that, we can take the fifth root on both sides, so that we can cancel the power. Okay, so I have fifth root of 2 equals to 1 plus r. So the r is equals to fifth root of 2 minus 1. I subtract 1 on both sides. So now let's use a calculator. Do you remember how to calculate the fifth root of 2? That is equivalent to 2 to the 1/5 power. Okay, I am going to calculate that on calculator. So after I calculate that, I'm sorry I skipped that, but I assume that you all be able to do it now. R is equals to, you still need to subtract 1, which is 14.86%. That is the growth rate. Okay, let's continue. After we found out the rate, we need to find out how many users will remain after a year. So remember, when we're doing the time, the unit of the time we're using is in month. So you need to make it the same, because the rate is the monthly growth rate, not the annual rate. So that means when we calculate how many users after a year, we need to convert it the year into month. Okay, so currently you have 120,000 users. 1 plus the rate, let me use 11486 to the time, 12 months. And now you should be able to do that with a Google calculator. So I have what? 1200 times 1.4 1.1486 to 12 months. So yes, after a year, your user would be 632,713 users will be on the website. Okay, so that's it. I want to recap a little bit about what we learned today. We learned about doubling time and half time. The idea is the same. It's not about the time, it's about the weight. How long does it take for the substance to decay to 50% of its original mass or quantity. So this is half time. So double time is the same idea. It's just how long does it take for the substance to grow to 200%, doubled of its original mass. So this is double time. Okay, when it comes to this kind of question, you always need to think about, hey, I want to calculate the rate first. Alright, that's it for today's lesson. Let me know if you have other questions.